Thank you. Now I'll be covering some of the issues and provide some constructive criticism on the paper. So for starters, privacy. It's curious that the word privacy itself only appears three times in the paper. It's interesting because this is a research paper that comes from Finland and Sweden, two European Union countries, and the EU, of course, has the GDPR, the General Data Protection Regulation Law. And while the paper itself mentions encryption and fraud detection, security and privacy are not synonymous. But privacy matters. After all, the paper foresees that the smart meters are continuously measuring and sending data to a central collector, and this can be directly accessible in real time and by other applications. The collector is reachable by all smart meters and historic information is stored. But as I'll cover later, even the industry standards for these are not yet set. And while no clarification is provided on privacy, on the face of it, it seems like it could be a relatively simple fix. For example, what if the data could be stripped of identifying information? Can the data be stored and processed on the edge instead of this central collector? Can, by using this, only the data by using only this, the data exposed to the grid utility or to anyone else can be can be controlled to the absolute minimum for fulfilling the smart meter functions listed in the paper. Furthermore, privacy doesn't have to be just partly the responsibility or fall on the consumer, to take charge of. It can also be partly the responsibility of, for example, the manufacturer of the smart meters to provide the features in their devices and to the grid utility or the grid operator or utility to guarantee the appropriate use of the data. The Going on to the next slide, there are several points that were also brought up in the paper, and these points are mentioned as needing to be fulfilled in order to to realize the dream and the promise of the smart grid through cloud computing. But these will increase the complexity and the time it will take to achieve this, and it's also not clear who will bridge these gaps and when will it happen. Uh, for to start with point number one, the paper mentions that authenticating distributed power resources and utilizing it during times of need requires what it calls complex trust relationships, which can be improved by adopting solutions from either distributed ledgers or wireless sensor networks. Yet, as this paper seems to suggest, like this doesn't yet exist, so industry must provide these solutions. Another point is the vehicle to grid system, in which the grid provider acts as the middleman between the consumer and the grid. For this to happen or to be improved, a fog node would need to be added to a vehicle to enhance the communication and verification. Yet car manufacturers must start including this in vehicles, though the paper does say this has already started. But it will also fall on the consumer to upgrade their vehicle or get a new vehicle, and both of these are not simple tasks. Dual use routers and realizing the decentralized part of the of smart grid through cloud computing, the consumer routers can also serve as computer nodes as well. This will provide on-demand computation for applications, making the smart meter that bridge between the grid and the fog. But are only the end users and consumers can have these routers? Then the consumers must be willing and able to provide these dual use routers. Maintenance is also a question, as grid operators are going to have to monitor and maintain these devices if they so choose to, or are they just going to relegate this to the average citizen to maintain with no guarantee that they'll be looking after their devices even if they own them? Resiliency. For resiliency, to be fulfilled, there would have to be fog nodes that also provide caching services. And as an example and a comparison given by the paper is utilizing a set of batteries in the case of a localized outage. But the same question as before, who is going to provide these nodes? And considering it's a question of resiliency, this now becomes a critical need in the times of emergency. Like imagine during and after a hurricane. Another question is like, or that being said, is this now something that the government has to oversee? And also think about the function it serves. If the smart meters and the nodes themselves malfunction and are not able to restore power properly or regulate the electrical grid, the electricity coming to the water grid from a microgrid, that now becomes a danger to life, to public safety, and to physical infrastructure. Yet one can imagine that the monitoring and repair of a distributed network of meters and nodes is much more is more difficult to do simply because it's now distributed and not centralized. Continuing on with these points is latency requirements. As we see on the table to the right, many of these functions require very low latency. And some of these functions, yes, are convenient. And the functions being these are functions that the smart meters need to provide. So some of these functions are convenient, luxuries you could even say to have, but others are essential, such as fault detection and tamper detection. Are the telecoms able to provide such technology for low latency? Like at the time of this paper's writing, 5G was young and even still is relatively young, and it has issues, has low coverage, at least in the United States, and the signal strength itself provides much or provide is at a lower range of service than previous technologies. The paper also mentions smart appliances that for smart meters to really fulfill their promise, they must be able to interact with smart appliances to allow consumers to monitor and control the household's electrical usage. Yet then it'll fall on the consumer to purchase these appliances. And then we come back to the property question once again. The smart meter will now have this unprecedented view into the household. In theory, if you allow the smart meter to connect to these appliances, now you're providing data on so many things. Anything from at what time you cook, what time you shower, you watch TV, and use Wi-Fi. Finally, there's a question of interoperability. The paper itself profiles 8 smart meters from 8 different manufacturers and 13 different functions that the function being mostly listed on the same table that we see here on the right. Yet, so 8 meters, 13 different functions, you multiply that's many things that have to be covered by many different manufacturers. Yet, as the paper admits, the industry-wide effort for these interoperability standards were still "quote unquote" underway. So, adding up these points, it's clear that achieving the smart grid through fog computing is a complex task with work to be done by various groups, from manufacturers to telecoms to end users. And of course, there must be that willingness to work to achieve this as well. And continuing on, there's other considerations not quite mentioned by the paper. There is the question of commercial and industrial users. The paper only covers households, not other customers. As a professional in the electrical industry, I know that commercial and industrial customers can have, for example, a much different load profile than households. They could require multiple meters and could just have different requirements, such as different service guarantees. And I'm not even talking about like large commercial customers or factories. These could be small businesses which have a much different profile than households. And I think the paper could have benefited from mentioning this because even the mentions of the households and the characteristics of households were pretty sparse. Another point is the power requirement. The, the paper mentions everything from smart meters to fog nodes to other devices that require, as I mentioned before, low latency. There's also the need for constant monitoring, and for some functions also provide constant calculation. So all this suggests that these devices will have a high electrical usage. Who is this going to fall on? On the end users, the households that own the meters? But in the end, maybe this is okay as the cost of running the meters may and should be offset by the savings provided by these meters. Finally, is the coexisting of different power sources. Like it's not hard to imagine that in the near future, if it's not already happening, that a household will have, a common household will have 4 to 5 different sources of power. Consider, number one, the traditional connection to the electrical grid. Number two, a battery system on the house. Number three, solar panels. Number four, a natural gas line that provides heating. And number five, an EV that could feed electricity into the house in times of extreme need. Yet all these have potentially different providers and different manufacturers, and yet can drastically alter, for example, the load profile of a house. Just consider the case of solar that could turn the house from a consumer of electricity to a producer feeding into the grid. So a producer of electricity. A smart meter that can manage all that is, of course, the more it manages, the more beneficial it is for the consumer. But the paper doesn't make it clear if this case if this case is being foreseen in the use of smart meters. So with that, those are some friendly commentary and friendly criticism of the paper of what could have been done to improve. Thank you.